Ladies and gentlemen, a very good afternoon to all of you. Welcome to NUS ISS Learning Festival 2022. Thanks for joining us for this session, the overview of data analytics essentials. I'm Brandon Ng, and my colleague Christine Chong will join us in the subsequent section. This is our agenda for today, the essential of data and analytics. Data and analytics. What does it mean? This is an important saying describing the criticality of data, which is, without data, we are just another person with opinion. Please allow me to repeat. Without data, we are just another person with an opinion. We are looking at the superficial of data available to us. We may not be able to get the insights unless we deep dive into the data via different analytics techniques. In summary, we are seeing what we may not get eventually in the end of the data lifecycle. Organizations are moving from high-spec personnel opinion to data-driven decision-making organization. Now, this can be achieved via data and analytics journey. Typically, there are two main analytics roles in data science space, namely business analyst or business intelligence analyst. They are primarily focusing on business intelligence projects such as data warehousing for reporting and dashboarding. On the other hand, data analysts or data scientists focus on different analytics modeling from descriptive, diagnostic to predictive or even predictive prescriptive analytics. This diagram shows the involvement of data personnel in terms of typical data and the data analytics role and responsibility. With the intersection of data and business problem to be solved, the data and analytics roles in this spectrum spread from business and data analyst to data scientist or even data engineer. Of course, as to mention as well, there's an involvement of business user and business users. In terms of the analytics in decision-making organization, we're looking at the analytics maturity model from descriptive analytics, diagnostic analytics, predictive analytics, which only try to explain and explore the occurrences in the organization via data. However, there is no suggested action to be taken. Hence, prescriptive analytics should be carried out to achieve the higher level of analytics maturity in a typical organization, especially for decision-making perspective. Recently, the latest publication by Gartner shows the actual real-world behavior in decision-making via data and analytics. It is in interactive, incremental, overlapping, and non-linear manner. The intersection and interrelationship of data, analytics, and decision is basically shown in this diagram. Raw, meaningless data is transformed to be information, knowledge, and wisdom prior to decision making. Now, it is accompanied with proper data journey from data collection, data integration, and finally, data analysis. As can be seen from this slide, we are referring to artificial intelligence, machine learning, statistical techniques, and etc. Now, more importantly, they are mapped to the different stages of analytics maturity level. In summary, data, information, knowledge, wisdom, and decision hierarchical structure is corresponding to the maturity level of analytics in a typical organization. With the data and analytics, let's move on to prescriptive analytics. Referring to the latest publication by Gartner, Hype Cycle for Analytics and Business Intelligence 2022. One of the highlights I would like to point out is data storytelling. It is one of the important essential skills for data science space. Referring to this hype cycle, with the data storytelling put in place, data, information, and insights need to be presented and communicated with efficient and effective channels. Therefore, in business intelligence implementation, data warehouse is used to capture data. Storytelling mechanism play an important role. The data storytelling is to achieve the effective insights communication via dashboarding, as well as pervasive insights presentation via storyboarding. They are used to present the right information to the right person at the right quality and right quantity at the right place at the right time. This will equip the decision maker to be equipped with important insights for making the right decision. This is an example of insights presentation using dashboard as a data storytelling mechanism. It is implemented using either Tableau, Microsoft Power BI, ClickSense, Google Data Studio, and etc. This is an example of insights presentation using dashboard. What happens that in this case, dashboard design with placement of the right charts and graph in a typical dashboard to maximize the space in the dashboard as well as viewers pattern. So the heat map will illustrate the best practices in dashboard design. These are the two examples of the best practices in testing the right and good dashboard design. Now, this is an example of project done by a group of master degree students based on a certain case study, which is tackling Singapore's population challenges. Now, the student make use of data storytelling framework to derive the setting, also known as goal, problem, also known as questions, and measurement or KPI, also known as metrics. And finally, they'll be able to derive the analysis and insights as well as final decision. Prior to the actual implementation, the team started with dashboard design using prototyping method by sketching on paper or post-it note. This is to validate and verify the requirement of the dashboard with respect to the data storytelling framework. With a clear direction, the team started to work on the data management and data governance, data analytics, and data visualization. So in this case, the typical example is data management and data governance using Microsoft SQL Server, followed by data and analytics modeling with Python, SQL, and Tableau. To further confirm the requirement with actual business users, a prototype of dashboard is quickly developed in BI tool, in this case, Tableau, and demonstrated to the users. This to ensure that they get the buy-in and confirmation or sign-off from the user. Once the confirmation is done, the prototype will be improvised to be the final dashboard so that subsequently user acceptance testing and production can be deployed into the production. The next section we're going to share is related to predictive analytics. I will invite my colleague, Christine Cho, to join us to share more pertaining to predictive analytics.
Thank you, Brandon. I'm Christine. I'll now take you through the next section on predictive analytics. For the Gartner hype cycle on data science and machine learning, we see three emerging trends. Firstly, data democratization. Data science and machine learning has long past being just related just to expert data scientists. We see data science and machine learning being used by analysts across all parts of the organization. Secondly, data dynamism. Data science and machine learning is also used in combination with conventional analytics and business intelligence, and machine learning is also used together with other techniques, for example, optimization and also rule-based algorithms. Thirdly, data centricity. Organizations are actively focusing on data usage, data governance, data curation, and also several other data-centric capabilities. We also see opportunities to leverage data across different types of domains. For example, public web data, enterprise data, customer data, using text, image, audio, video, logs, and sensor data to achieve to get enriched data analytics as well as context enriched analysis. In terms of marketing applications, we see that data analytics can be used to assist managerial decisions. For example, whether to advertise, change prices, launch new products or service, assess the impact of marketing and communications effectiveness. For example, what factors or product formulations are important in driving product and brand choices, what prices to charge for different range of products, which advertising messages and campaigns are effective in getting engagement with stakeholders, as well as which customer segments should we target to drive conversion and improve profitability. Some emerging marketing trends include, for example, marketing mix decisions are increasingly made quantitatively instead of just qualitatively. For example, pricing decisions are routinely being made using dynamic quantitative models, and so are assortment, channel, and location decisions. Other trends include customer engagement. For example, machine learning algorithms extract consumer preferences from massive online data and help engaging text and images to attract attention. Thirdly, in terms of search engine, where many customer journeys begin. So besides keyword being the dominant form of online search, we also see machine learning methods being used to make searches based on other content types. For example, voice recognition, natural language processing, and text-to-speech capabilities. Last but not least, in terms of recommending the right products to interested customers, can also significantly improve marketing performance. In this regard, we see deep neural networks and also embedding methods being used to leverage and further enhance the performance. Other emerging trends, we can see examples of digital levers and enablers, for example, rapid experimentation and simulation for product and process innovation, real-time analytics, dynamic pricing optimization, connected product innovation for go-to-market commercialization. And thirdly, from big data to small and wide data using machine learning and as well as deep learning and AI techniques. In the space of statistical and machine learning actually arose as a subfield of artificial intelligence, while statistical learning arose as a subfield of statistics. These two are slightly different because machine learning has a greater emphasis on large-scale applications as well as predictive accuracy, and is a more data-driven perspective, whereas statistical learning emphasizes models, interpretability, and is more theory-driven. So there's a balance between theory-driven versus a data-driven perspective by injecting human insights as well as domain knowledge into the use of machine learning techniques. We also see the wide use of structured data, which comprise of clearly defined data types with patterns that make them easily searchable, as well as unstructured data, which is comprising of data that is usually not as easily searchable, including formats like audio, video, and social media posting. Examples of structured machine learning problems are, for example, quantitative demographic and behavioral data, like, for example, identifying the effects of demographic and marketing data on insurance policy product purchases, predicting housing prices based on different types of demographic and social data, establishing the relationship between marketing promotion as well as, for example, location, advertising on store purchases. Examples of unstructured data are like image, text, speech, voice data, etc. For example, customizing an email spam detection system based on frequently occurring words, predicting user interaction and engagement on social media postings, predicting positive versus negative sentiments based on attributes of internet movie ratings. Several trends in machine learning have arisen in recent years. For example, machine learning methods are well positioned to extract rich insights from rich data. While studies have frequently analyzed text and image data, we see that there are opportunities to focus on audio, video, and consumer tracking data, as well as network data and data of different hybrid formats. There's also opportunities to broaden and extend usage of machine learning techniques. So while machine learning techniques are frequently used for prediction and feature extraction, they can be harnessed for other types of analytics, for example, causal and prescriptive analytics. Other trends include opportunities to broaden and extend machine learning usage in the entire customer purchase journey, to develop decision support capabilities covering all aspects of the marketing function, from more strategic areas, for example, brand positioning, competitive analysis, to more operational areas like customer satisfaction and service delivery improvement. Okay, machine learning tasks can be broken down into a few types. The first is supervised learning, for example, predictive and forecasting techniques, where the outcome is actually called the dependent variable or the response or the target versus a set of predictors or features. This comprises regression versus classification problems. The second class is unsupervised techniques, for example, segmentation, association, where there's no outcome variable, just a set of predictors or features measured on a set of samples. And the key idea here is to find groups of samples that behave similarly, find features that behave similarly so that we can get useful information that can be used as a pre-processing step for supervised learning. Other new emerging machine learning tasks include semi-supervised learning or transfer learning. For semi-supervised learning, the output is only known for a subset of the data. For example, in transfer learning, researchers leverage an existing model trained using a different data set or for a different purpose. In the area of active learning, only limited training instances are available at first. So the goal is actually to maximize the predictive accuracy while minimizing the data requirement. An example is reinforcement learning, where the learning agent continuously interacts with the surrounding environment by taking actions and observing feedback. The learning algorithm then needs to determine the actions to take to both learn the environment's characteristics and the optimal policy given the states. Now we shall zoom in into supervised learning, the feature selection methods. This can be broadly classified into three areas. The first is subset selection. First is to identify a subset of predictors that we believe to be related to the response, and then we fit a model using, for example, a least squares method on the reduced set of variables. This first type is quite common, commonly used, and most people are familiar with this method. The second method is called dimension reduction, where we project P predictors into an M-dimensional subspace, where M is smaller than P. This is achieved by computing M different linear combinations, and then these M projections are then used as predictors to fit a model. The third type is called shrinkage or regularization methods. This apply for a large sparse data set. We typically fit a model that includes all the predictors, but the estimated coefficients are then shrunken towards zero relative to the least square estimate. This method allows the effect of having reduced variance, and it can also help to perform variable selection. Feature selection methods, there are different types. Some are linear, some are non-linear. For example, if we want to predict income based on social demographics and survey data, example, age, education, and seniority, etc., we can either fit a linear model or non-linear models. Some models can fit both linear as well as non-linear models, and we call these flexible models. So there are some models, for example, like least squares method. For example, like least squares, decision trees. They could be more flexible, but there are some models that is less interpretable, like for example, neural networks. In the space of dimension reduction as a feature selection method, for example, if we need to predict income based on social demographic and geolocation data, if we have many predictors, we can also reduce them to a subset, for example, n dimensions. So these smaller m dimensions can then be used to fit a model. Last but not least, for example, in the area of credit card assessment based on demographic and behavioral data, if there are too many predictors, we can also use the regularization method, where we keep our original set of predictors, but these coefficients are being shrunken towards zero, so that it has the effect of reducing variance and fitting a good model. Examples of big data learning problems are in the space of, for example, social media, movie ratings that we see on the internet. Big data vary in shape. For example, some can be white data. So white data refers to data where we have many millions or thousands of millions of variables, but we only have a smaller number of samples. On the other hand, tall data, we have probably few hundred variables, but we have much more number of samples. So these are called tall data. We also have tall and white data, which comprises maybe thousands, millions of variables or millions of samples. So big data vary in shape and they call for different approaches. Examples are, for example, internet movie ratings using machine learning and deep learning. So typically for movie reviews and book reviews, we can use a sequence of words occurring in a document to make prediction about the label for the entire document. Examples of techniques include machine learning and deep learning approaches using recurrent neural networks, which can be used for classification, sentiment analysis, as well as language translation. Another example is in terms of image recognition in social media context using machine and deep learning. Neural networks can be used. An example is convolutional neural networks. It has evolved in recent years for classifying image, such as for a wide range of problems. The recent trend has been moving from big data to small and wide data, especially after COVID period, where many of the historical data are now getting more redundant. So organizations may have a smaller subset of data, even though there can still be many thousand or maybe millions of variables. So we call this sparse dataset or small and wide dataset. An example is online shopping analysis using models on large sparse data. So in this case, the marketing analyst may be interested in understanding people's online shopping behavior. We could treat this online shopping behavior as features. As features based on all the search items entered by the users into the search engine. This is sometimes known as a bag of words model. And based on the bag of words that the users key into the search engine, we can then build a model to predict the click-through rate. Even though we may have only a limited number of samples, we can employ large sparse models to create effective models for this type of small and wide data. Another example is web page browsing analytics using models also on large sparse web page session information. So if we have data that is maybe, for example, 5 minutes internet sessions, behavioral data on users who browse the web page, and these are web page indicators and descriptions which are available, and we can use it again to predict what is the conversion rate. Okay, so what we have seen so far belong to the class of observational data. That means in observational data or studies, researchers are only observers. So we measure what people do or say. For example, internet purchase behavior. They would do in the same situation that is not of their own making. Okay, so on the other hand, when we compare this with conducting experiments, researchers control the important variables that influence consumer behavior. This will allow us to more precisely measure the effect. So in comparison again, in observational studies, researchers don't really assign choices. We only observe what is happening. So I observe what users are doing on the internet or what they buy from historical transactional purchases. As compared to, in contrast to experiments, where researchers manipulate factors, they create a treatment and then they compare the response. So now let's do some quick analysis on observational studies and data. Some examples include primary and secondary market research and trends. These include structured and unstructured data that we have seen previously on social media. It could be knowledge of consumer immersion. An example is ethnography, where we go into the consumer's natural environment and we look at what they do, what they do on a normal daily basis. Or we could extract value based on connected products, for example, sensors, so that we can look at real-time analytics from smart sensors, for example. The third type of observational data or studies include quantitative data. This include direct questioning, buy response surveys, or transactional data that we collect from our historical database. Okay, an example of ethnographic observational studies is ethnography. Ethnography is a type of observational research that can be enabled by both offline and online tools. It is a convenient way for participants to share how they interact with products and services in their natural environment. Now we shall see an example of an ethnographic case study of IKEA shoppers.
Interior designers must be comprehensively equipped to create supportive, responsive environments. From hospitality to workplace and healthcare to retail, the demand for multidisciplinary solutions is formidable. Like William White did in The Social Life of Small Urban Spaces, we observed IKEA shoppers and mapped their meanderings. The biggest secret to IKEA's success is its maze-like spatial organization, designed to obscure a path to the exit. Shoppers meander along a 12-foot wide public street, continually distracted by fully accessorized private rooms to the right and the semi-private salon to the left. IKEA's other secret is the shortcut. We were interested in how many people take the shortcuts and why. The shortcut option allows an out for those who feel a loss of control by being confined to the street, like cutting through an alley. In exercising their freedom of choice and the need to break away from the herd, our study revealed that 40% of IKEA shoppers take the shortcuts, because shortcuts give people a sense of autonomy. People need to make their own rules on how to use space, proving that user autonomy is essential to successful interior design. Another observation that intrigued us was shoppers' interaction with the merchandise. Who samples what, how do they sample, and for how long? People tend to go where other people are. The reason for this is the human act of crowding. We observed that strategically placed product, augmented by color, lighting, and pricing, attracts the first herd member, and then others follow. Retail strategies designed to attract, engage, and ultimately get shoppers to purchase owe their success to consumer psychology. As the environmental psychologist Paco Underhill says, if we went into the stores only when we needed to buy something, and if once there we bought only what we needed, the economy would collapse. IKEA's environment provides shoppers with just the right sense of belonging, freedom, and safety. We also notice that verbal engagement varies with gender. Men engage in conversation 52% more than women, while women, consumed by spatial interaction, are seriously focused on shopping. How important and applicable are the lessons of human behavior? The human-centered approach to design places users' needs first, and good design is ultimately judged by how conducive it is to human experience. Incorporating psychological, behavioral, social, and cultural research methods enables designers to identify strategies by which to create a reciprocal relationship between space and its users.
Okay, so just now was an example of an observational studies. So now let's move on to experiments. Why experiments? Experiments allow analysts to answer business questions that is related to cause and effect. It's important for us to know whether, for example, in an umbrella, let's say if we want to forecast whether it will rain or not, it's important for us to know whether it is an umbrella problem or whether it's a rain dance problem. For example, if what we want to know is whether we should carry an umbrella, then this is actually a prediction problem, and causal questions are of little value, secondary importance. We only need to know whether the probability of rain is going to be high or low. So this is more of a prediction problem. On the other hand, if there has been a long drought and we want to end it, then prediction is of little value. In this case, causal questions are of primary importance to us. So for example, if we want to induce rainfall, What we need to know is what variables cause the rain and then try to manipulate these variables. So this is where experiments come in. Examples of business experiments include A/B testing using hypothesis testing methods. An example is to compare landing pages to see which type of landing pages could generate more sales. If we have, and that is only just one variable, which is the different types of landing pages. If we have multiple types of variables, we can use predictive analysis, for example, screening designs, factorial designs, conjoint analysis, to study how different variables interact together to create more sales or higher impact for the business. Business experiments can also be used for marketing analytics. For example, looking at what type of customers, what are the right channels, or the right communications that we can target during the awareness stage, consideration, and the purchase stage. Now I shall forward to Brandon to let me continue on the next section on prescriptive analytics.
Thanks, Christine. Let's move on to the next section with prescriptive analytics. We have shared descriptive analytics, predictive analytics, and now prescriptive analytics. Due to digital disruption and digital transformation, digital business will drive decision complexity and require more advanced techniques for solving real-world business problems. This need to combine the capability of predictive and prescriptive analytics, depending on the nature of problem to be solved, as well as complexity of the potential solutions. There are three main types of predictive analytics and two types of prescriptive analytics. It is important to combine both groups of analytics techniques in order to exploit their respective strengths. They are used to complement each other rather than compete with each other. In the recent publication by Gartner, optimization is one of the emergent AI technology which will have an impact in near future. There are a lot of techniques in operational research which are used for optimization purposes as well. It involves a wide spectrum of techniques such as linear and non-linear programming for single objective optimization, Go programming for multiple objective optimization, queuing model for operational analytics, 2. Learning curve for capacity analytics. Supply chain analytics, the network analysis for traveling salesman problem. This is an example of famous traveling salesman problem to be solved with optimization in terms of fastest travel time, cheapest travel cost, and shortest travel distance. It is solved with genetic algorithm, which is an AI technique. Inventory optimization and simulation. This is another important technique commonly used in analytics using Monte Carlo simulation. There are uncertainty factors in business setting for a typical organization. In other words, the business scenario is in non-deterministic or stochastic manner. Hence, Monte Carlo simulation is the alternative solution. This is a showcase of demand-driven supply chain using simulation tool for goods supplying from manufacturer to distributor, wholesaler, and retailer. Ladies and gentlemen, besides static data for statistical analysis and time series data for forecasting, spatial data play an important role as well in decision science, typically geospatial data. And this brings us to locational analytics to answer the question of where questions. This diagram shows a frame of spatial temporal visualization for location information. Sensing of location information and sense making of collected detail for geomarketing is one of the critical success factor in commercial excellence journey. So this is a simulation of geospatial data visualizing the check-in, check-out of a typical customer. Next, operational analytics, or prior to that, retail analytics for in-store operational excellence. It is crucial in pushing the commercial excellence with real-time streaming analytics.
In today's highly competitive marketplace, grocery retailers strive to create a seamless shopping experience that drives sales and builds loyalty with their customers. IoT-connected devices such as beacons, video cameras, digital signage, and smart shelves provide access to huge amounts of new data on customer activity and present more opportunities for sophisticated insights and immersive customer engagement. IoT data is used to track the effectiveness of store layouts, exposure to promotions, product interactions, and use of digital kiosks and mobile apps. This data is analyzed in real time to create deep insights into customer preferences and path to purchase. Digital Assistance allows customers to find the items on their list, interest them in new products, and select promotions to save money. And for marketers, identifying customer desire, delivering curated content to upsell and cross-sell, and measuring the success of promotions has never been simpler and more accurate. IoT provides service-level metrics and enables store managers to eliminate long queues, schedule staff efficiently through cognitive intelligence, and make sure customer expectations are being met at every service point in the store. IoT, revolutionizing the retail experience.
As you see, retail analytics making use of streaming analytics via IoT sensors to collect data and analyze the behavior of the customers. The next one is operational analytics. It is used to analyze foot traffic for demand planning as well as management purposes via queuing model. Like it is making use of queuing theory. So, foot traffic analytics for demand planning and management using queuing model as optimization techniques is appropriate to carry out operational analytics. For example, the number of counters and staffs for vaccination center to be deployed, as well as at the vaccination center, as well as the clinic during the COVID-19 pandemic. All these are example of how we be able to handle and plan ability of organization accordingly. This is another example, the cloud at the supermarket, for example, NTUC Fair Price or cold storage. So with that, please allow me to share the learning pathway you can join us to attend different individual courses or a bundle of courses, which eventually will stack up to be the grad certificate and eventually the master degree as the final destination for all of you in data science space. Once again, thank you very much for joining us for this session. We value your feedback for our NUS ISS Learning Fest webinar. So do scan the QR code and give us your valuable feedback. Thank you so much. Ladies and gentlemen, also, we would like to understand you better in terms of your data and analytics journey or your involvement in data space in your organization. To provide us your video feedback by filling up a Google form. You may scan this QR code to access the Google form accordingly.
Okay, so while waiting for the questions to come in, maybe Brendan, you want to share what is the difference between predictive versus prescriptive analytics?
Okay, sure.
Participants.
Yeah, thanks, Christine. Now, what happens in industry, all cases all company are about their journey to predictive analytics. More importantly, the issue is that all cases where the company or the decision maker would like to know the actionable item to be taken. So with the situation here, predictive are looking at the forecasting and prediction, mainly for time series training or even classification problem. However, in prescriptive analytics, we're referring to optimization, rules, as well as simulation, which basically to recommend to the human decision maker what are the best options to be taken so that they can solve the business problem at the optimal level in that sense. Yeah.
So maybe we can look at what are the applications of predictive and prescriptive analytics. In the area of predictive analytics, we see the application of, say, customer analytics, using prescriptive and predictive analytics to look at demand forecasting for new and existing products. We can also use it for marketing and sales optimization, sales force effectiveness, so on and so forth. How about Brendan? Where do you see the applications of predictive and prescriptive analytics in organizations that you have worked with?
Okay, sure. So typically, for example, one domain is supply chain analytics. Due to the nature of the marginal profitability per se, other companies are skipping the predictive and move on to optimization, which making use of prescriptive analytics techniques. Now, this is to ensure that they make use of current constraint given to them and make the best out of it by having an optimal solution. Now, having said that, due to the pre-COVID, COVID, and post-COVID situation, the data collected in the past 2 years may not representative in terms of the actual business occurrences in the typical organization. So with the situation, it's more so for us to really to push the limit to prescriptive analytics to ensure that we always at the right choice of the action, making use of the optimal solution. So for example, supply chain, route optimization, or even inventory optimization, right? Because now the shopping behavior by different customers can be quite different in that sense.
Okay. We can also look at analytics at the strategic level and also at the operational level. For example, at the strategic level, we can use analytics for product, marketing, sales optimization. So, Brandon, where do you see analytics being used at, say, the operational level?
Okay, so typically based on the operational, the typical case is that they get the directional in terms of analytics from the top management. For operational, in more micro level, I foresee that, for example, queuing model being used to ensure that they do a proper capacity analytics and resource planning accordingly by having an optimized and the proper allocation of resources to handle the cloud, for example, in the vaccination center, and the shopping market, and etc. Now, more importantly, to avoid wastage of the procurement or even storage at the warehouse in terms of inventory optimization, sometimes the tactical and operational team may make use of Monte Carlo simulation to simulate so they be able to predict at the same time, optimize accordingly via parameters calibration. Yeah.
Okay.
So these are the few examples that always happen in industry.
Okay, we're also interested to hear from you. What level of analytics is your organization at? So please feel free to share with us your opinions via the QR code. So give us your feedback.
Is there any questions? Ladies and gentlemen, you may want to put in the chat box so that we can answer you accordingly. Okay, earlier on, Christine mentioned that there is machine learning and deep learning. What you foresee in terms of the directional in industry? As you can see, that sometimes there's a converging of the different techniques from different domain and move on to that direction.
Well, we see the use of various types of machine learning as well as statistical learning techniques Well, machine learning tends to be a bit more data-driven, whereas for statistical methods, it tends to be a little bit more top-down or value-driven, but both are complementary. We see both complementing each other to help organizations to uncover insights alongside with other latest techniques like, say, reinforcement learning, transfer learning, so deep learning techniques. All these are useful to help organizations to look at both structured and unstructured data.
Okay, sure. Maybe I'll just add on. In the past, people mentioned that business rules, for example, decision support system, expert system, tend to be obsolete in that sense. But in fact, it is kind of complementary for optimization techniques using prescriptive analytics or more to the operational research techniques, as well as rules, which basically try to cater for the needs of the different dimensional of problem to be solved accordingly. So they're supposed to be complementary rather than competing each other in that sense. And of course, need to highlight as well, simulation become more important due to a lot of uncertainties or non-deterministic environment, which is the nature of the real business world problem. That's why all these are converging to have under a big umbrella of data analytics for us to solve a typical sophisticated business problem via appropriate techniques accordingly.
So there's a question coming in. Hello, I'm a beginner in the data analytics space. And the person wants to know if he or she wants to start learning, what would be the first 3 steps to take? I.e., which part of data to start with. So I believe in this area, for beginners, it's good to start along the analytics journey. So like what Brandon has mentioned, starting from descriptive analytics, understanding more about data through visualization, and also using tools like Tableau to help with visualization, and progressively moving on to more advanced techniques like predictive as well as prescriptive analytics. So it's good to start from more basic level of analytics. Brandon, what do you think?
Yeah, I think that's a good answer to the question. More importantly, I think you need to start to love statistics or mathematics or operational research as a technical skill. On top of it, you like to work with data, how to handle the data accordingly. And more importantly is that which domain you're coming from. Because typically for data analytics, you're referring to make full use of data via technical techniques to solve a business problem in the real world situation.
Yeah, so Brandon is right. So it's besides the data part, the more important question is what is the business problem that we are trying to solve? So knowing the business problem from the business statement that the stakeholders are interested to solve is the very first point. And from there, finding the right data, the right techniques to help you uncover insights and to solve the business problem becomes more and more important. Yeah. Okay. Do we have any other questions from any participants? If not, we'll be closing this session very soon. Thank you very much for your participation, and we hope to hear from you, your feedback, opinions via our feedback channels. Thank you very much for coming to our session.